This is the video for simplifying radicals. Okay, so whenever you're simplifying just a radical like this, you're just going to make a factor tree. 20 is 2 times 10. 10 is 2 times 5. You've got two 2's. Remember, you're always looking for a set of the index. So in this case, the index is 2. So every time there's 2 of something, you're going to bring it out front. And then whatever's left, I always box, and that goes on the inside. So this is going to end up being 2 square root of 5. Alright, 36 is 6 times 6. And since there's 2 of them, you bring a 6 out front. And you should just know that one by heart. 64 is 8 times 8. Since there's 2 of them, you can just bring it out front. But that's another one you should just know by heart. 8 is 4 times 2. And 4 is 2 times 2, so you have a set there, and then this is left over. So you bring 1 2 out front and leave 1 2 inside. Okay, 10 square root of 30. 30 is 3 times 10. 10 is 5 times 2. So there is nothing that repeats. So you just leave it 10 square root of 30. Okay, so here you have negative 4 times cube root of 640 times the cube root of x to the 8th. Okay, so I'm going to do 640 first, which is 8 times 80. 8 is 4 times 2, and 4 is 2 times 2. And then 80 is 10 times 8. 8 is 4 times 2, and 4 is 2 times 2. And 10 is 5 times 2. So now because your index is 3, you're looking for sets of 3. So that's one, and that's one. And then these stay inside, and you'll multiply them together. So that means I have negative 4 times, you've got 1 set, 2 sets. So that means you're going to bring both of them out, which is 2 times 2, so that's 4. And then it's always going to be the cube root, because that's what you started with, and 5 times 2 is 10. And then here, you can look at it this way. Draw 8 x's if you want. And then your sets of 3's. You have 2 sets of 3, and then 2 left over. So that means you're going to bring an x squared out front, because x times x is x squared. And inside my cube root is also going to be an x squared. So now we're just going to look on what's on the outside and what's on the inside. So we've got negative 4 times x squared, which is negative 16x squared. And then cube root of what's on the inside, 10 times x squared, is 10x squared. And that's your answer. Okay, so here you've got negative 3 times the square root of 243 times the square root of v to the 4th. So let's do 243 first. Let's find the factors of 243. We've got 9 and 27. 9 is 3 times 3. 27 is 3 times 9. And 9 is 3 times 3. So because my index is 2, we're looking for sets of 2. And then this one's left over. So I've got negative 3 times. I've got 2 sets of 2. So you multiply the 3's together to get 9. And then we have the square root of 3 left. And then back here, you've got 4 v's. So 1, 2 means I'm bringing 2 out front, and there aren't any left over. You can also look at it as the index is 2. How many times does 2 go into 4? 2 times. And then if you have any left over, they stay inside. So now let's multiply the outside. Negative 3 times 9 times v squared is negative 27v squared. And then all that's left inside is the square root of 3. Okay, so same thing here. Negative 8 times the square root of 567 times the square root of b cubed. So let's find our factors of 567. So I've got 7 and 81, and 81 is 9 and 9. You don't need to break down 9 and 9 anymore because you've got 2 of them, so you can go ahead and bring those out front, and you're left with just a 7 behind. So I've got negative 8 times 9 square root of 7 times, now look at here, the index is 2. How many times does 2 go into 3? 1 time. So that means 1's going to come out front. And how many are left behind? 1, so 1's going to stay inside. Multiply the outside, and you get negative 72b. And then multiply the inside, and you get square root of 7b. Okay? So again, we've got negative 8 times the cube root of negative 576 times the cube root of x to the 9th times the cube root of y to the 10th times the cube root of z squared. So let's do this one first. 576. First off, because it's a negative and it's a cube root, I know that when I pull things out, it's going to be negative. So 576 is 9 times 64. 9 is 3 times 3. 64 is 8 times 8. 8 is 4 times 2, and 4 times 2. And then 4 is 2 times 2. So this time we need 3, so that's a set of 3, and that's a set of 3. So you're pulling out a negative 2 and a negative 2, which is going to give you positive 4. And then you're left with the cube root of 9, because there are 2 3's left. And then here, how many times does 3 go into 9? 3 times, and it's even, so there aren't any left over, so there aren't any that stay inside. How many times does 3 go into 10? 3 times. So we're going to bring a y cubed out front, but then we're still left with a y on the inside because there's 1 left over. And then here, we can't do anything because we need 3 of them and we only have 2 of them. So that's just going to stay cube root of z squared. So now multiply the outside. Negative 8 times 4 times x cubed times y cubed is negative 32 x cubed y cubed times the cube root, and let's do the inside. 9 times y times z squared, which is 9y z squared. And that's your answer. And actually, that should be positive, because when this should be negative. You'll bring out a positive 2 and a negative 2. So I was incorrect on that. All right, let's try this one. Negative 3 times the 4th root of 189, which means something's going to have to repeat 4 times in order to bring it out. 4th root of p to the 5th, 4th root of q to the 3rd, and 4th root of r to the 7th. So let's do 189 first, which is 9 and 21. 9 is 3 times 3. 21 is 7 times 3. Oh, and this is a misprint. This should be the cube root. Okay, that's what's wrong. So these should all be cube roots. You had a little typo there. So it's the cube root, not the 4th root. So you only need something to repeat 3 times. So I have 3 3's. So I'm going to bring out a 3, and then I have the cube root of 7 left behind. And then here, I have 5. If I take 3 of them, I have 2 left. So that means I'm going to bring a p out front. And then I'm left with 2 p's on the inside. And then here, if I take out 3, that's all of them, so I'm just going to bring a q out front. And then here, how many times does 3 go into 7? 2 times, so 2 r's come out front, and 1 stays inside. So let's multiply the outside. Negative 3 times p times q times r squared. So that's negative 9 p q r squared, and then cube root of 7 p squared r. Okay, so I've got 9 times the 4th root of 810 times the 4th root of m to the 7th times the 4th root of n to the 10th times the 4th root of p to the 9th. So we'll start with 810, which is 81 times 10. 81 is 9 times 9, 10 is 5 times 2, 9 is 3 times 3, and 9 is 3 times 3. So I have a set of 3, and then 5 times 2 is staying on the inside. So 9 times 3, 4th root of 10, times, how many times does 4 go into 7? 1 time, so 1 m comes out front, and you're left with 3 m's on the inside. How many times does 4 go into 10? 2 times, so 2 n's come out front, and 2 n's are left behind, because 4 into 10 is, or 4 times 2 is 8, so there's 2 left behind. And then how many times is 4 going to 9? 2 times. So I bring 2 out front, and then you're just left with 1 behind. Okay, so let's multiply the outside. 9 times 3 times m times n squared times p squared is 27 m n squared p squared times the 4th root of 10 m cubed n squared, oh, this should be a p, silly me, p. Don't worry about the absolute value on the answer key. This is the correct answer. All right, and last one, you've got 3 times the cube root of 1125, cube root of m to the 6th, cube root of n to the 6th, and cube root of p to the 9th. Okay, so 1125 is 25 times 45. 25 is 5 times 5. 45 is 5 times 9. And 9 is 3 times 3. So we can bring a 5 out front. And we're left with the cube root of 9 because there's 2 3's left behind. 3 goes into 6 2 times evenly, which means we're going to bring 2 m's out front. And then same with the n's. And then 3 goes into 9 3 times, so we're going to bring out 3 p's. So multiply the outside. 3 times 5 times all of these is 15 m squared n squared p cubed, and then it's cube root of 9. And that's it.